Theorem is theorem 9.3. So let us see what does the theorem say. The perpendicular from the center of a circle to a chord bisects the chord. Okay. So according to the theorem, let's construct the required things on the circle. So this is the circle and this is the center. So let me first mark the center as O. Now let us make one chord as the question mentions a chord. So let's have a chord. Okay. And let us name the chord as AB. So this is A, this is B. And now what does it say? The perpendicular from the center of a circle. So let us draw a perpendicular from the center of a circle. So this is the center and we are gonna draw a perpendicular. This is the perpendicular. Let us mention it 90 degree. Now what we would be doing, we would be joining AO and BO to make two triangles, because in all the theorems except one in which we have to show the angle subtended by an arc at the center is twice, except that in all the theorems we have to prove with congruency, so obviously we will need that. Now what we have to prove is, we have to prove that this perpendicular bisects the chord AB. So let us mention this as D. So now what we can write in RTP is RTP that AD is equal to BD. AD is equal to BD. This is what we have to show, as the theorem says perpendicular from the center of a circle to a chord bisects it. So bisects the chord. So okay, let us prove it. Now as you can see, AO and BO are the radii, so they would be equal. We have one of the angles which is 90 degree each, so we have got one angle, then again one angle. And now as these AO and BO are equal, we'll also have one more thing. We'll get these two angles equal. I think you all know the property of isosceles triangle. The angles opposite to the equal sides of a triangle are equal. So let us take two triangles, triangle AOD and triangle BOD. Now we'll be proving it by like angle side, as we can see it clearly, angle side, angle side. So we take angle ODA is equal to angle ODB, each 90 degree. Okay, angle. Now again one angle OAD is equal to angle OBD. Okay, this I have told you what is the reason behind it, so I'd be writing in short, which is AO is equal to BO. That is why AO is equal to BO, but in exam you will be writing the whole reason. Now we have one side which is AO is equal to BO, and the reason is radii. So therefore we have triangle AOD and triangle BOD congruent, so they are congruent. Now what is the criteria? It is angle side. So by angle side they're congruent. Now RTP was AD is equal to BD, so let us see AD is equal to BD. AD is equal to BD, reason by CPCT, and this is what we have to prove. So hashtag proved. I hope you all would have understood. What we did was, we took two radii, and when these two sides of this triangle were equal, it was an isosceles triangle. And in an isosceles triangle we have two of the angles equal, which is the angles opposite to the equal sides are equal. So we have, so friends, the next theorem is, which is again the converse of this theorem. It is theorem 9.4, which says that the line through the center of a circle to bisect a chord is perpendicular to the chord. It says that when we draw a line which bisects the chord, means AD is equal to BD. We are understanding in the same diagram which I made for the theorem 9.3. As I won't be proving it, it is a converse. It is very easy. I'd be just giving you idea and you will prove it by your own. It is given AD will be equal to BD, and what we have to prove is perpendicular. We have to now next we have to prove it perpendicular, but it is given that it bisects. So again the same diagram would be made, and the same two triangles will take, but this time we'll take side angle side, side angle side. Okay, now after proving congruent, we will get angle ODA is equal to angle ODB. Okay, now as you can see, these are linear pair also, as ADB is a straight line. So angle ODA plus angle ODB is equal to 180. So we'll write two angle ODA is equal to 180 and angle ODA is equal to 90 degree. So this is how we'll be proving the Theorem 9.4, which is the converse. So let's move forward to the next theorem. So friends, the next theorem is Theorem 9.5. Let's see, what does it say. It says that the equal chords of a circle are equidistant from the center. Okay, so according to the theorem, we have made the construction. It says equal chords of a circle. So PQ and RS are the equal chords. These both the chords are equal, are equidistant from the center. Means what we have to prove is basically OL is equal to OM. RTP OL is equal to OM, as it is saying to prove it equidistant, and the distance between PQ and the center is OL, and between RS and the center is OM. So we have to prove them equal. OL is equal to OM. So now how to prove it? As we have PQ is equal to RS, and in the last theorem we saw that the perpendicular drawn from a center on a chord bisects it. It means you can see this is a perpendicular, so PL will be equal to QL. So if we have written PQ is equal to RS, so half of PQ is equal to half of RS. This means if PQ is equal to RS, so definitely the half of PQ will also be equal to the half of RS. So in this case, the half of PQ will be what? PL, as OL bisects PQ. So half of PQ can be written as PL is equal to what? Half of RS, which is MR. Okay, so we got one data, which is PL is equal to MR. Okay, now I think we have got all the things to prove this theorem. I said we'd be again proving it congruent, two triangles, which could be triangle OPL and triangle OPL and triangle ORM. Okay, so now let's take these both the triangles. We take triangle LOP and triangle MOR. Okay, so first, what do we have? This angle. We can prove it by RHS, as we have one right angle, we have hypotenuse, and we have one side. So angle OLP is equal to angle OMR. OLP, this one, is equal to OMR, this one, 90 degree each. Okay, this is the reason. Now R. Now we need one hypotenuse, which is OP and OR. Now why OP and OR are equal? Yes, it is radii. We can see this is the center. These both will be equal as their radii. Now we got R, we got H. Now we need a S, as we have proved earlier. PL is equal to MR. So we write LP is equal to MR, proved above. Okay. Now therefore triangle LOP is congruent to triangle MOR by RHS. This implies LO is equal to MO. LO is equal to MO by CP, CT, and hashtag proof. This was what we had to prove. LO is equal to MO means this is equal to this, and hence these two equal chords, which are PQ and RS, will be equidistant from the center. This is the center, and the distance of the PQ from the center will be same to that of the distance of RS from the center. So let us see the next theorem. So friends, the next theorem is the again converse of this theorem, which I won't be proving, but I will be telling how to prove. Chords equidistant from the center of a circle are equal in length. Okay, so in this we will be getting the chords equidistant. Means in that case, if we take the same diagram, we will have OL is equal to OM, and now what we have to prove is PQ is equal to RS. So definitely we'll be again taking these two triangles, but this time different criteria would be used. This time we can use side, angle, side. Okay, side, angle, side we will be using, and PL is equal to RM we will get. Now as OL will bisect PQ, you know by the theorem, perpendicular drawn from the circle to a chord bisects it. So we will get PL is equal to RM. So twice of PL is equal to twice of RM. Now what we will get? PQ is equal to RS. So I told you how to prove it. It is very easy. It is just the converse. So let us see the next theorem. So friends, the next theorem is the angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. So now basically this theorem says that whatever angle will be subtended by an arc, for example in this diagram, the angle subtended by the arc PQ is that POQ will be double then subtended by the same arc on any other part of the circle. So in examination point of view, from the examination point of view, if you have to prove this theorem, you will be drawing all the three diagrams, but you will prove it with only one, anyone. So we'll be proving it with this first one. So I have drawn this first diagram over here, and now let us prove it. So as you all know, the exterior angle sum property of the triangle. So this angle will be equal to the sum of this and this angle. So let us write angle BOP is equal to angle OPA plus angle OAP. Okay, exterior angle sum property. Okay, this is the exterior angle sum property. Now, as you all know, OA and OP are radius, so these both the angles will be equal. So what else we can write? Angle BOP is equal to twice of angle OAP. We can write, okay? So we can consider it equation 1. Now let us move on to the another side. Angle BOQ, this angle. Let us do the same with this. Angle BOQ is equal to angle OAQ plus angle OQA. Exterior angle sum property. Okay, now angle BOQ is equal to twice of angle OAQ, as this angle and this angle will be equal, as O and OQ are the radius, so the angles opposite to the equal sides are equal, so is equal to twice of angle OAQ. This will be equation 2. Now we add equation 1 and 2. So angle BOP plus angle BOQ is equal to twice of angle OAP plus twice of angle OAQ. So BOP plus BOQ is equal to angle POQ, and we take 2 common in bracket angle OAP plus angle OAQ. So we can see here triangle angle OAP, which is this one, plus OAQ, which is this one. So in whole it forms this angle, which is PAQ. So it will be equal to angle POQ is equal to twice of angle PAQ, and this is what we had to prove. So hashtag proved. Okay, so these were the main theorems from the point of view of examination, and we had proved all the theorems, and I had made you understand what are the converse of the theorems. So I think now we are done with the video. So thank you all for watching. All the best for your respective exams.